All right, this is the second screencast. Arjun, please stop tipping your chair. Thank you. Okay, in this screencast, I'm going to go over integrating expressions of this form. Sine raised to a power times cosine raised to a power. All right, we're going to be looking at integrating expressions of this form, and I'm going to only hold you accountable to one type, okay? And the one type is going to be this. If the power of m and or n is odd, okay? So, and what happened here was I did this screencast and then I hit a button and lost it. So I'm sorry, I have to kind of talk as I'm writing here, but hopefully, do you see my cursor here? I hope you can. Okay, so what we're looking at here is a power of sine times a power of cosine. And the situation I'm going to hold you accountable for is if m or n, if m and or n is an odd power. Okay, what do you do in those situations? I'm going to show you what happens if m and n are both even, but I'll tell you right now that what happens is you just kind of get into a hare's nest of algebra that, frankly, is something you are never, ever, ever going to see, ever. I won't put one on a test. It just gets to be arduous and algebraically so dense, okay? Even integrals like this that I'm going to show you in the screencast, I'll be honest with you right now, these do not appear on the AP. I will show you what does appear on the AP, and that's the type that of this form that we've already seen. It's when you have, like, say, sine x cubed, for example, without a cosine x, all right? So, okay, let's take a look at this. Here, let's take a look at take a look at these two integrals that I start off with right here. In both cases, do you notice, let's take a look at this one first, that sine is raised to an odd power, cosine is raised to an even power. And here's what you do. When you have a situation where the integrand is power of sine times a power of cosine, you're going to first, right here, peel a sine x off. Okay, you're going to peel a sine x off, and with the remaining sine to the fourth x, you're going to rewrite using the Pythagorean identity. Look below. You know that sine squared x equals 1 minus cos squared, which means then sine to the fourth x is going to be 1 minus cos squared x all squared. You're going to then replace this in for sine to the fourth x right here. Then the algebra, I told you this is just very algebraically heavy. Look what happens. You're going to multiply out this binomial, distribute cos to the fourth. And when you do that, look at my pen here, you get this, okay? At this point, you're going to do a u sub, let u equals cos x, du equals negative sine x, and then et cetera. Everything else falls into place very nicely, okay? So this is how you deal with integrands where one of the powers, what be they sine or cos, is odd and the other one is even. You take the odd power and you peel one off. So let's say, for example, this had been cosine to the 7th x and sine to the 4th x, you do the exact same thing here, but you would peel off a cosine x, and that cos to the 6th, you would use this identity. Obviously, you'd solve it for 1 minus sine squared and replace, distribute out, and do a u sub again, okay? So now you know how to deal with integrands where you have a power of sine times a power of cosine, and one of those powers is odd. Here's what happens if they are both odd. If they are both odd, you're going to choose one of them to peel off. You could choose sine x or you can choose cosine x. One is not more difficult than the other. I'm just going to peel off a cosine x. Here is my peeling off, right? Cosine x right there, okay? Peel a cosine x off. That leaves you with cosine to the 4th x. Same thing over here. You're going to use the Pythagorean identity. Notice how cos to the 4th x just equals 1 minus sine squared, because that's cos squared after all, squared. And then you're going to multiply this all out right here, multiply it all out, distribute sine to the 5th, and then you're going to let u equal sine x, and etc. Okay, simple sub. So that is what you do when you've got a power of sine times a power of cosine, and one or both of those powers is odd. Okay, and I should say at this point too, you know, especially for you seniors, this process right now of just grinding through all the different ways to integrate, it is mind-numbingly grinding because it's not contextual. There's no application. We haven't seen like a nice application in a while, have we? It's just grinding through methods of integration. And, this is, believe it or not, if you can believe it or not, you probably cannot, but back in my day when I learned calculus, the number of integration methods was 3 times what we show you now in high school, mainly because it was agreed upon at some point, I think it was around the mid-'80s, that really for a student to be good in calculus, it has very little to do with just knowing all these very esoteric ways to integrate. So we pluck like 4 or 5 that we think is good for you to know, and the others we just say, you know what, it's just really not necessary. Okay. The other variation here that you are attended to, that you should know how to do, are variations we've seen before. We get something like this: the indefinite integral of sine squared x dx, which you've done before. I'm going to say it right now for posterity and for recording purposes. Officially, you've heard from me that you need to know the cosine double angle identity. It goes without saying, you also have to know the Pythagorean, but you need to know the cosine double angle identity. And in particular, you need to know these 2 forms. There are 3 total. If you want the third one, I'll give it to you here. Cos squared x minus sine squared x. You need to know these, and in particular, you're going to need to know, you want to know these 2. 2 cos squared x minus 1 and 1 minus 2 sine squared x. Here's why. Because when you have this integral, you're going to rewrite sine squared x as, look, watch over here, as 1 minus cosine of 2x all divided by 2. This equals sine squared x. All I did here was just rework this equation and solve it for sine squared x. And then what I'm going to do over here is I'm going to go back and substitute in indefinite integral of 1/2 minus cosine of 2x over 2 dx. And maybe you want to write this as 2 separate indefinite integrals. Indefinite integral of 1/2 dx minus 1/2 indefinite integral of cosine of 2x. Oh my gosh, dx. And then at this point, simple. Right here is a simple u sub. Let u equals 2x, etc. Okay? All right. Let's see. The last possibility, and this one actually is included in this case, if m or n is odd, right? How about this one? What do you think about something like this? The indefinite integral of cosine of cubed of 4a dA. Let's just play around with dummies for a little bit. Why don't you try it on your own and then replay me for the answer? I'm going to work the solution out right now. All right, I'm going to do this. I'm going to peel a cosine off. This becomes the indefinite integral of cosine of 4a times cosine of squared of 4a dA. And this, I know, I can write as 1 minus sine squared of 2a. So now what I have is the indefinite integral, 4a. Indefinite integral of cosine of 4a times 1 minus sine squared of 4a dA. Okay, I'm going to now let u equal the sine of 4a. That means du equals 4 cos of 4a dA. Hi. And Ms. Amaya, say hi to my class.
Hi, everybody.
Hi, everybody. She's so happy. Okay, and then what happens is we substitute back in, we get, ready? 1/4 the indefinite integral of 1 minus u squared du. Okay? ... And then you continue from here. All right? So at this point, let me make something very clear. The homework is written below. It is all just integration, 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 integration. When I see you on Monday, we are going to, and see down here, this is M and M both being even. I was doing this out, so I'm just going to have you look at this. I was doing this out, showing you what you had to do here algebraically. And I look over to Miss Whitney and I said, you know what? They are literally never going to need this esoteric way solving integral. I'm just going to bail. Like, I'm not going to show it to them. You just don't need it. You just don't need to worry about this. But anyway, on Monday when I see you, we're going to circle up. And I want to see every single integral that I assign up on the board. You all decide among you, who's going to put up what. At the very start of class, you are all going to have agreed. Jasmine, say hi to my class. This is Jasmine from TFA. She's here to do some trigonometry. Don't you wish you were back in the days of trigonometry? This is BC calculus. That's the class I told you where I was like, I got myself stuck, and Nancy and Jason they just sent me they gave me like they sent me a life raft. I was telling Miss Whitney's class this. I walked and I said, you know what? I just had Nancy and Jason. They saved me. And I think, you know what, I'm going to give Nancy, Nancy, take this marker. Why don't you just teach this class, Nancy? You just teach the class. And they just all laugh. She's amazing. All right, the point is, Monday, you're each going to have agreed upon and decided what integral you're putting up. We're going to take a look at them, and then we're going to get right back on and do the last, yes, I said it, the last integration method of the year. Goodbye, and have a great long, long weekend.